In this second video on atomic theory, we're going to look at the contributions of Ernest Rutherford and the model that was developed called the Planetary Model of the atom. Ernest Rutherford followed up on the model that was developed by J.J. Thomson's cathode ray tube experiment and William Thomson's plum pudding model. He was doing experiments in 1909. Ernest Rutherford spent most of his time in New Zealand and the United Kingdom. What he did is he was studying the way that high-speed positive particles, known as alpha particles, and alpha particles basically the equivalent of the nucleus, what we later discover is the nucleus of a helium atom. 2 protons, 2 neutrons. And he was taking these alpha particles, which were positively charged, relatively high mass, high speed, and shooting them towards atoms that had a very large mass, like gold, platinum, copper, and tin, metals that could be made very thin, and these particles would travel through these metals. What he did is basically fire these alpha particles at a piece of gold foil. That's why it's known as the gold foil experiment. Around the gold foil was a detection screen, a piece of paper that would light up whenever an alpha particle passed through it. So as the alpha particles hit the gold foil and went through the gold foil, he could see on the screen where the alpha particles were hitting. So basically, here's a little diagram of the experiment. You have the source of alpha particles, a beam of particles created. You put a screen around the gold foil, and the particles are shot towards the gold foil. And we see the way the particles interact with the individual atoms of gold. Now, what Rutherford expected based on the plum pudding model was that the particles would travel straight through the gold foil. The alpha particle was much larger than any of the electrons. The plum pudding model had said that the rest of the atom was this positive charge area, so there was nothing with anywhere near as much mass as an alpha particle. So you expect an alpha particle to travel straight through the gold foil. However, when he did the experiment, he saw that occasionally those particles would bounce at a large angle or even bounce back towards the source. This was an incredibly surprising result that did not match the plum pudding model in any way. Rutherford is actually quoted as saying that this makes about as much sense as shooting a large cannon at a piece of paper and having the cannonball bounce back off the large piece of paper towards the cannon, which makes absolutely no sense from what we would expect, and this result of the experiment made about as much sense to Rutherford when he did it. So we needed a new model of the atom, something that explained these results. Rutherford expected all the particles to just travel straight through, but occasionally we would see these particles deflect at large angles. This suggested the presence of a very massive, positively charged area in the atom. So we come up with 3 conclusions out of this experiment. The atom has a very dense center, which we call the nucleus. The nucleus has a positive charge due to the small positively charged particles known as the protons. And the electrons reside at a distance very far from the nucleus in relative terms. Remember, the nucleus is incredibly small. So an electron being very far away doesn't have to be very far in what we think of as a scale of like centimeters, but it is very far in comparison to the size of the nucleus. So the atom must have a lot of empty space. You can almost think of it as if the nucleus was a basketball at the center of the Georgia Dome, the electrons would be filling up a space larger than the entire Georgia Dome. So we come up with a new model. So his experiment disproves the plum pudding model. We have to develop a new model of the atom. And this new model involves a positively charged nucleus containing pretty much all of the mass of the atom that was very, very, very small and very dense, and a huge amount of empty space around the nucleus where the electrons reside. This model is known as the planetary model of the atom. Niels Bohr is eventually the one who comes up with the description of it, and we'll learn all about Niels Bohr when we come back to atomic theory in the spring. But this is commonly referred to as a planetary model. It was the simplest idea that we could come up with to explain what this model looked like. A small very massive, very dense center compared to the rest of the space of the atom, kind of like the sun. Very, very large object compared to all the planets, but very small in comparison to the entire solar system. Very dense that everything else orbited around. So that's where we get this idea of the planetary model of the atom. We're going to leave atomic theory at this point. This gives us enough of a background into atomic theory to understand the things we're going to cover this fall semester. We'll come back to atomic theory in the spring when we touch on what's going on with the electrons. But for right now, we need to understand that there are protons and neutrons. The neutron, the other particle in the atom, is not discovered until much later by James Chadwick. The protons and neutrons have significantly large mass and they make up the nucleus. We have the electron in a very large empty space around the outside. And you can see the progression of this model. Democritus saying that there were atoms. Dalton saying that they're uniform spheres. That model sticks until an experiment disproves it, that experiment being the cathode ray tube experiment. Cathode ray tube experiment shows that that model can't be correct. There must be something smaller than the atom, which was the electron that J.J. Thomson had discovered. So now we come up with the plum pudding model of the atom by William Thomson. After William Thomson explains the plum pudding model, Rutherford's gold foil experiment shows that the plum pudding model can't exist, and we end up with now the planetary model with that very massive, very dense, very small nucleus containing the protons and neutrons with electrons in a very large space around the outside.